All right, scholars, we're going to be graphing parabolas today. And so the first thing we're going to do is make sure that we find the A, B, and C first. And when I say A, B, and C, I mean the standard form of a quadratic is written like this, where A is your coefficient to x squared, B is your coefficient to x, and C is your constant. C is also your y-intercept in the standard form. And so when we look at that problem, we can graph those. Let's say, for example, y equals x squared minus x minus 6. The first thing I'm going to do is identify my A, B, and C. My A, or my coefficient to x squared, is 1. My B, or my coefficient to x, is a negative 1. And my C, or the constant, is a negative 6. I'm going to use that to find my axis of symmetry. The axis of symmetry is the imaginary line that goes down the center of the parabola, and it's going to be very important later on. And so, the formula for the axis of symmetry is x equals a negative b divided by 2a. Now, you might want to think of that as the opposite of b. Negative inherently means opposite, right? And so, if we are talking about the opposite of b, then you want to switch the signs or take the inverse of that sign. So say, for example, b is a negative 1. Well, the opposite of b will be a positive 1. And so, the opposite of b is positive 1. Divided by 2 times a, or 2 times 1. Well, 1 divided by 2 times 1, or 1 divided by 2, is 1/2. And so I'm going to start my table off with an x value of 1/2. I'm going to put it in the middle of my table, though. The reason why I'm going to do that is because this is also the x value of my vertex. It's the axis of symmetry and the x value of my vertex. So I'm going to circle that, because I know it's going to be my vertex. And so when I graph this, I'm going to choose some other x values for my domain here. I'm going to choose x values that are integers and greater than 1/2, let's say 1 and 2, and x values that are integers and smaller than 1/2, let's say 0 and negative 1. Well, let's input 1/2 in and find out what y we would get if we put in 1/2. All right, so I'm going to have y equals 1/2 squared minus 1/2 minus 6. Well, 1/2 squared is 1/4 minus 1/2 minus 6. 1/4 minus 1/2, or 1/4 minus 2/4 is a negative 1/4 minus 6. Well, these numbers have the same sign and I'm subtracting them. So, same sign, you add and then keep that sign. So, negative 1/4 minus 6 is a negative 6 1/4, or you can say a negative 25/4, whatever suits you. Whatever your teacher needs. All right, and so remember I told you that concept symmetry would be very important later on. So I'm going to take this 0 and I'm going to plug it in here for x. 0 squared minus 0 minus 6. 0 squared is 0. 0 is 0. So I'm only left with the negative 6. This is where the symmetry comes in handy. Think of a butterfly's wings. The middle of the butterfly's body would be the axis of symmetry. Its wings would be the things that are symmetrical. And so, further up, the wings are the same distance away from each other. The middle, they are also the same distance, and lower down, they are the same distance away from each other. Think of the butterfly's wings. The parabola works in a similar way, meaning if this is the middle, directly through the middle, and on the other side that is of equal distance away from the middle, the values will be the same. So 0 will go to negative 6, and so will 1. Let's check this. If I plug in a 1, that's 1 squared minus 1 minus 6 Well, 1 squared is 1. 1 minus 1 is 0, doing your work from left to right. And 0 minus 6 is a negative 6. So it all worked out using symmetry. Let's do it again. Let's try 2, and then 2's y value would have the same y value as negative 1. All right, let's put in 2. 2 squared minus 2 minus 6. I'm using this equation here. That's 4 minus 2 minus 6. That's 2 minus 6, and that's a negative 4. So 2 would go to negative 4, and so would negative 1 go to negative 4, using symmetry. It's very important if you're going to use symmetry that you use integers that are of equal distance away from your axis of symmetry. And so I'm going to graph 1/2 negative 6 1/4. Here's 1/2 on the x-axis, negative 6 1/4. Go down 6 spaces, and go down a little smidgen for 1/4 there. Negative 6 1/4. 0, negative 6. Here's 0. Here's negative 6. Let's do negative 1, negative 4. Negative 1, negative 4. Let's do 1, negative 6. 1, negative 6. And 2, negative 4. 2, negative 4. And so our parabola will have a smooth curve with arrows indicating that it goes up infinitely. And we've graphed it. Let's do another one. Plus 3. This one is a little funny because when I identify my A, B, and C, I'm going to notice that one of the numbers is missing. Remember, A is the coefficient of x squared. So that means A is 2. B is the coefficient of x. Well, I don't see an x. And when you don't see an x, that means the coefficient of x is no thing or nothing. And the number that represents nothing is 0. The constant, or the number that is not attached to a variable, is 3. And so now I'm going to find the axis of symmetry. X equals negative b divided by 2 times a. Negative b is 0 divided by 2 times 2. 0 divided by 4 is 0. So I'm going to create my table. And so I have 0 in the middle as the x value of my vertex in my axis of symmetry. I'm going to pick 2 points, or 2 integers that are greater than 0, 1 and 2. 2 that are smaller than 0, negative 1 and negative 2. If I plug 0 in, I'm going to have 2 times 0 squared plus 3. Well, 2 times 0 squared is 0. And so I'm going to end up with a y value of 3 there. Let's plug in 1. If I plug in 1, now remember, excuse my dear Aunt Sally. Girl, excuse my dear Aunt Sally. Grouping symbols first. I see that that isn't a grouping symbol, but even more important, that's an exponent. Exponent comes before multiplication. And so I'm going to square 1 first. 1 squared is 1. Then I'm going to do my multiplication. 2 times 1. And 2 plus 3 is 5. Now remember, we're using symmetry here to find our other values. So since these are of equal distance away from 0, I can say that negative 1 also has a y value of 5. Order of operations, exponents first. 4. 2 times 4 is 8, plus 3 is 11. So I also know that negative 2 goes to 11. Using even numbers here, so my odd integers are going to be in between the even numbers. And so I have negative 2, starting with the first point there, negative 2, positive 11. Negative 1, 5. So negative 1 would be in between 0 and negative 2. And 5 would be in between 4 and 6. 0, 3. 1, 5. 2, positive 11. Smooth curve. And you've just graphed another parabola. Let's do another one. Right? Y equals a negative 3x squared minus 6x plus 5. Let's go ahead and create our XY chart because we know it's coming. Identify your A, B, and C. A is negative 3, B is negative 6, C is 5. Axis of symmetry, x equals a negative b, or the opposite of b, that's going to be 6, divided by 2 times 3, or 2 times negative 3, 2 times your a. And that's going to be 6 divided by negative 6, which is a negative 1. So our axis of symmetry is negative 1. The x value for our vertex is negative 1. I'm going to choose integers that are greater than negative 1, 0 and 1, and less than negative 1. Negative 2, negative 3. And so I'm going to start plugging those things in. Let's plug in negative 1 first. Negative 3 times negative 1 squared minus 6 times negative 1 plus 5. Negative 1 squared is a positive 1, so that's 3 times 1. Negative 6 times a negative 1 is a positive 6 plus 5. Negative 3 times 1 is a negative 3 plus 6 plus 5. Negative 3 plus 6 is a positive 3 plus 5. That's going to give me 8. So my y value that corresponds to the x value of a negative 1 is 8. So my vertex is negative 1, 8. Another thing that we haven't been doing that I'm going to need you to do is we need to find out whether this graph has a maximum or a minimum. If your a is positive, then your graph is going to have a minimum. If your a is negative, then your graph is going to have a maximum. Minimum means you can see the graph's lowest point. Maximum means you can see the graph's highest point. Remember we talked about you had to draw the arrows because the parabola is going to go infinitely in one direction. If it goes infinitely up, you cannot see its highest point. But if it goes infinitely up, you can see its lowest point. Right? So that way, if we can see its lowest point, it has a minimum point, or a minimum. All right, let's start plugging in some of these other numbers. This cancels out, this will cancel out, and I'm just left with 5. Because of symmetry, the negative 2 also has a y value of 5. Let's plug in the 1. Negative 3, 1 squared, minus 6, times 1, plus 5. 1 squared is 1. Negative 6 times 1 is a negative 6, plus 5. Negative 3 minus 6 plus 5. Negative 3 minus 6 is a negative 9 plus 5 is a negative 4. Now we have all our points we can graph. Once again, this is going to be a maximum because our a is negative. All right, let's start from the top. Negative 3, negative 4. Negative 2 and positive 5. Negative 1, positive 8, 0, 5, and 1, negative 4. So here's our parabola. Draw a smooth curve, smooth as possible. Sorry, mine isn't so smooth. Make it as smooth as possible for you. And so you can see that its highest point, that's its maximum. Let's do some where we have to solve for using the graph. And so I would graph it like usual, so I'm going to make a table. I'm going to save you some of the steps here. I'm going to find the vertex. And so it's going to be 6 or negative 6 divided by 2, which is going to give me a negative 3. Find 2 numbers higher than that. And so that's going to be negative 2, negative 1, and 2 numbers lower, negative 4, negative 5. I'm going to find the values y values that correspond with those x's. So I'm going to plug in negative 3. That gives me 9. That gives me a negative 18. 9 minus 18 is a negative 9. Plus 10 is 1. I'm going to start plugging in other values. Let's plug in -2. -2 squared is 4. That's going to be -12. 4 minus 12 is a -8. -8 plus 10 is 2. So that means the -4 also has a y value of 2. Let's plug in -1. -1 squared is 1. 6 times a -1 is a -6. 1 minus 6 is a -5. -5 plus 10 is 5. And so let's get ready to graph this. All right, let's start from the top here. -5 and a +5. -4 and a +2. -3, a +1. -2, +2, and -1, +5. Now, as you notice, we're not going to get a solution because this graph does not cross the x-axis. The solution of a quadratic is found, that's why they call them zeros, is found, or roots, because it's rooted on the x-axis, is found when your graph intersects the x-axis. This graph does not intersect the x-axis, therefore there are no real roots. So we want to write that, no real roots. Your book uses a symbol to describe that. They use that symbol there, null set. And so, but I want you to know that means there are no real roots. It doesn't mean the roots aren't there. It means the roots aren't real numbers. The roots are going to be complex numbers or imaginary numbers. But that's okay. We're not going to get into that now. I just need you to know that there are no real roots. Let's do another one. All right. We're going to do one where you're graphing and your answers or your roots or your solutions or your zeros aren't going to be integers. Let's talk about it. So let's create our XY table again. And I'm going to save you some work. Find the axis of symmetry. It's going to be the opposite of B. That's 2 divided by 2 times 1. 2 divided by 2 times 1 is 1. Then I'm going to find two numbers higher than 1, 2 and 3, and two numbers lower, 0 and -1. Let's start to graph this. And so I'm going to look at this and see I have, let's start from the beginning, smooth curve here. All right, let's see if we can, as you can see, it crosses the x-axis at these points. It intersects the x-axis at these points. Problem with that is it's not an integer, right? We can state the answer, but we don't know exactly where it crosses graphically. And so we're going to write it as an inequality. It obviously crosses between the numbers -1 and 0. So I'm going to write that. In between -1 and 0, you state that by putting an x in between them and two less than symbols, meaning that -1 is less than x. Here's x. -1 is obviously less than that. But x is less than 0. Here's x. 0 is greater than x, or x is less than to the left of 0. Let's look at the next solution. 2 is less than x, but x is less than 3. Let's recap that. 2 right here is less than x, but x is less than 3. So I have s squared plus 8s equals a -15. Before I start this, one thing I want to do is write spaces, because I know I'm going to have to complete the square. So I'm going to have s squared plus 8s. I'm going to leave a space, and I'll tell you why in just a minute. Equals a -15. I'm going to leave another space. I'm going to leave this space because I'm going to make a perfect square here. That's the whole purpose of completing the square, to make or create a perfect square. You do that by taking your b, 8, dividing it by 2, and squaring the result. That's going to give me 4 squared, which is 16. So I'm going to add 16 to this equation, right? But I can't add it on one side without adding it on the other. Equations need to stay balanced. So I'm going to add 16 to the other side as well. Recognize that this is now a perfect square. So I can rewrite this. I can rewrite this as s plus 4 squared. Why, you ask? 4 times 4 is 16. 4 plus 4 is 8. It's a perfect square. Trinomial. All right? 16 minus 15, or negative 15 plus 16, is 1. To solve, you take the square root of both sides. Square root cancels out the square. I'm left with s plus 4 equals, the principal square root of 1 is 1. The true square root of 1 is a positive or a negative 1. Subtract 4 from both sides. S equals a negative 4 plus or minus 1. Negative 4 plus 1 is negative 3. Negative 4 minus 1 is a negative 5. Those are my two roots, my two solutions, my two zeros. Let's try another one. So I'm going to leave spaces. A squared minus 10a equals negative 24, and another space. Complete the square. Take your b, divide it by 2. Square the result. I'm going to have negative 5 squared. A lot of people are going to say that equals negative 25. But I'm squaring a negative 5. Negative 5 times negative 5 is a positive 25. I'm going to add 25. But if I do it on one side, I have to do it on the other. I'm going to have a minus 5 squared equals, that's 1. How, you ask? Negative 5 times a negative 5 is a positive 25. Negative 5 plus a negative 5 is a negative 10. Square root both sides. I'm going to have a minus 5 equals a positive or negative 1. Add 5 to both sides. Once we do that, 5 plus 1 is 6. 5 minus 1 is 4. I'm going to add 7 to both sides to get the constant out of there. I'm going to have 2b squared minus b, leave my space, equals 21, need a space. Now I realize that this 2 is here. To complete the square, I need to get rid of that 2. So I'm going to divide everything by 2. I'm going to have b squared minus 1/2 b, my space, equals 21 divided by 2. All right. Half of b, half of a negative 1/2 squared. Half of a negative 1/2 is a negative 1/4. Squared is a positive 1/16. So I'm going to add 1/16 to both sides. You have to be good at fractions. Make sure you're using fractions. Don't be afraid of them. They're wonderful. And so, I can't add these unless they have the same denominator. Multiply by 8 times the top and the bottom, or the denominator and the numerator. This is a perfect square, right? 1/4 times 1/4 is 1/16. Or negative 1/4 times a negative 1/4 is a positive 1/16. Negative 1/4 plus a negative 1/4 is a negative 1/2. So I can write this out as b minus 1/4 squared. Now, this is going to be 21 times 8, which is going to be 168, plus this 1, 169. And I'll tell you why this is going to come in handy. It's very nice. And 16 is my denominator. So I'm going to take the square root of both sides. That's going to be b minus 1/4 equals the square root of 169/16. Whenever you square root a fraction, you square root the numerator and square root the denominator. Square root the numerator, then square root the denominator. So I'm going to get plus or minus. The square root of 169 is 13. The square root of 16 is 4. Add 1/4 to both sides. I'm going to get b equals 1/4 plus or minus 13/4. Now I can do the math and find my roots, my zeros, or my solution. 1/4 plus 13/4 is 14/4. which can be reduced to 7/2. 1/4 minus 13/4 is going to give me a negative 12/4, which can be reduced to negative 3. And so here are my two roots, 7/2 and negative 3. Wish you luck on your quiz.